Hello, 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 hello. I hope you all are doing great. So we are going to solve a JEE problem. This is, I think, JEE Main's problem. And this problem is like a application of dot product. Okay. So we have given that we have two particles. Wait a minute, I'll tell you here. So we have two particles, this particle and this particle. This particle is A and this particle is B. Both are thrown with velocity VA and particle B throw with velocity VB, and ask that in the question calculate the time when the velocity of both particles are perpendicular to each other. This is the question. Means just like we know that this particle go with this path and this particle go with this path, and ask that calculate the time when the velocity of both particles are perpendicular to each other. Velocity of both particles will perpendicular to each other. So just imagine how these particles are going to move. Like this particle will go like this and this will go like that. So at this stage the direction of particle is here, at this stage the direction of particle is here, and if we extend the direction, like just see that this is the direction of particle and this is the direction of particle, the projectile they follow. Okay, so we have to calculate around this position the particle direction is here, around this position the particle direction is here, and if you extend it beyond it, then you show that this is 90 degree. So we have to write the velocity of particle at these 2 points, and we know that the kinematics, we use the rules of kinematics and calculate the particle of the velocity at these 2 positions. Okay. Okay, so first deal with the particle B. Just like they follow this path, and we have to calculate velocity here. Then here the velocity is same, VB in x direction. We know that in the x direction the velocity haven't changes because the acceleration in x direction is 0. What about the velocity VB in y direction? Then Vy is equal to Uy plus Ayt. There is no velocity in Uy direction. Then Uy is equal to Ay into t. Ay is equal to minus g because the velocity, the acceleration towards negative direction, into t. Then Vi is equal to minus gt. So the velocity of particle in y direction after time t is minus gt. This is the velocity. Then after same here, this path follow. Then we can write that similarly using analogy. Va is equal to same direction is here, direction is here. Va is equal to, no, not Va. Va after time t is equal to Va I cap minus V I cap minus gt. This is the velocity of A after time t. Velocity of B after time is equal to VB I cap minus gt j cap. Now what we have to do that, just take a dot product of these two velocity is equal to minus VA I cap minus GT J cap VB I cap minus GT J cap. When you take dot product, minus VA VB plus G square T square, and we know that if both are the perpendicular to each other, the dot product should be 0, equating the value VA VB is equal to G square T square. From here, T is equal to root VA VB by Z. This is the answer. That's all. So we get this answer. Like, there are many type of questions asked in JEE on this concept. Like, I'll tell you one question. I'm not gonna solve it, but I'll tell you. Just like there is a projectile and thrown here at angle theta with velocity u. Okay, and they also ask that calculate the time at which the initial velocity and the velocity both are perpendicular to each other. There is nothing. Just write this velocity in I cap j cap, and here velocity in I cap j cap. Take a dot product, and using kinematics you can easily get the answer. There are a lot of questions asked on the concept of just the application of dot product. So we get time is equal to root VA VB by Z. This is the answer. I'll again revise it. Like, we have two particles. This particle go like this. This particle go like this. And we have to ask that calculate the time when the velocity of VA and VB are perpendicular to each other. Then we say, like just imagine this particle is here. Just imagine this particle stay here with velocity this direction. Then how this velocity changes, like this, like this, like this, like this. And when it's just ready to hit the ground, then both are perpendicular. But here the question is not that this is stable. The question is that this is also move with velocity VA, this also move with velocity VA. Like, just imagine both are here and here. When both are like here and here, both are like that and that. So at this time, like around this position, both are perpendicular to each other. Then we have to calculate this direction. We use the simple basic kinematics equation. Taking a dot product, we get the answer. That's all for this video. Thank you. Bye bye.